Okay, in this video we're going to go over this example right here that has to do with linear equations and then graphs of linear equations. And there are two types of linear equations. Remember, we've got standard form, ax plus by. This is if you see an equation that has x and y, but not in slope-intercept form. It's probably in standard form. And then we have slope-intercept form, which is the form that we need in order to be able to graph it. Or this is the type of equation we would create if we were given a graph. And in slope-intercept form, we've got the slope, which is our m value, and our slope, remember, is the rise or the change in the y value over the change in the x value, some sort of rate, right? We're comparing the two quantities, how much they're changing by each time. And then b represents the y-intercept, and it's a constant, right? So some number that's being added or subtracted when it's in slope-intercept form. And x and y are always seen as variables, but we know that x and y are coordinates, so they are points on the line, and they are, because they're points on the line, they're considered to be solutions to equations. So the first thing I'm going to do here is just kind of look at the line and figure out what the equation for this line is without even really attacking the question. So if we're looking at this line, we've got a point that we want to find crosses the y-axis. We want the b value. So mx plus b. B value is where it crosses, and looks like here it is crossing the y at -2. So we know that our y-intercept is -2. And then our slope, we're going to need another point to figure out what the rise over the run is. So I'm going to look to see where does it cross the corner, because I know if it crosses perfectly in the corner what that coordinate is. It looks like it's crossing perfectly right there. And then we can go ahead and count the rise over the run. So it rises once and it runs once. So our rise is 1 and our run is 1, which 1 divided by 1 is 1, and the slope is positive. So we've got a positive slope, we've got a slope of 1, we've got a negative y-intercept, right? How do I know it's positive? Because the line is increasing in the x values as it's increasing in the y values. A negative slope, for those at home, would be when the x values are getting larger, the y values are getting smaller. That's a positive slope, sorry. This is a negative slope. And then obviously a constant slope would be flat. So let's go ahead and answer the questions. A point on this graph is 1, 3. Well, we just created the equation for our function, or our equation. So we have y equals 1x minus 2. So if this is in fact a point, then what we can do is we can test that out by either looking to see, okay, 1, 3. Well, let's go to 1 on the x. This is our x, so we're going to go to 1 on the x, which is right here, and 3 on the y, which is right here. So that point should be right here. That point is not on the graph, so this is not a solution. I'm going to go ahead and put, or this is not an answer, because that is not a point on the graph. It's not a point on the graph. A point on the graph is implying a point on the line. The equation y equals x minus 2 models the line of this graph. Y equals x minus 2. Well, if you look at the equation that we made, we have y equals 1x minus 2, and we know that 1 times x is y equals x minus 2. So yes, it does. This is good. Maybe I should use a different color. We can use maybe blue. This is good. This is a solution. Just to verify that it is for sure, we can also put this into Desmo. So y equals x minus 2, and I can kind of look, okay, is the line the same? Let's see, that point right there is 0, -2. This point right here is 0, -2. Good. It's crossing the x. It looks like at 2, which means it'd be 2, 0. It's crossing at 2, 0. Okay, this looks like the same line. Good. Just wanted to test it out. The graph could represent the income of the owner of a pinball machine that was purchased for $2 and cost $1 to play. So let's come back to this example because it's a little bit more complicated. The solution to the equation for this line is 4, 2. Well, there's two ways to tell, right? We can just look at the graph. 4, 2. Let's see. 4 for x, 2 for y would be right here. So that would be this point right here. Yes, this is in fact a solution. Another way of being able to tell is by putting in 4 for x in our equation. So we have 4 minus 2 and 2 for y, and then simplifying to see if we get the same number. So 2 equals 4 minus 2 is 2, 2 equals 2, good, it's a solution. The equation has a negative slope. Well, we've already identified that the slope here was positive, so this is not a solution, or this is not a box that we would check. The line has a positive y-intercept. Well, our y-intercept was a negative. It's going through a negative, so this is not one that we would check. The change in y is the same as the change in x for the slope of this line. Well, our slope here was 1 over 1. If y is changing 1, then x is changing 1, then that means that they're changing by the same amount. So we can say, yeah, they're changing equally. So we've got three answers right now. We've ruled out the first one. So let's go back to C. And the graph could represent the owner of a pinball machine that was purchased for $2. So this guy spent $2 up front, and we're talking about his income, and cost $1 per play. So when I'm reading this, I already know what my M value is, because my M value is the rate, and the rate is something that is, being multiplied per play. So it's $1 per play, and this is a constant. He bought it for $2. It's initial purchase, starting value. He started in the hole $2, so I know that this is my B value. So the equation here would be y equals 1 x, and that's a positive, or he spent $2, so it would be minus, because he spent it 2. And that is the same exact equation that we get up here. And that makes sense, because if you're an owner of a pinball machine and you're buying a pinball for $2, then you're going to start in the hole $2, and then after one person plays one game, they've paid $1, you now only are in the hole $1. After somebody plays the game for the second time, you've made $2, so you're back to even, you're back to 0. And then by the third play, you're starting to make money. Now you've made $1 by the fourth play, you've made $2 by the fifth play, you've made $3. So you can see that this line models this particular question, so we can go ahead and say this is also a solution.